We're doing some more power supply reviews today. Today we're looking at a budget class power supply. We've already looked at a lot of expensive ones. The Gigabyte power supply is obviously the most famous out of the ones we've looked at, but we also took the EVGA Supernova power supply recently through a series of tests to see how one that doesn't explode is supposed to behave. Now we're working our way down to the $55 class. So this puts us finally in budget tier where a lot of people are buying, and our goal over time is going to be to work on a lot of these types of power supplies in maybe the $40 to $80 range to figure out a comparative set of data, who's best at what. This is the Cooler Master MasterWatt 650. Cooler Master can't get enough of its own name. It puts it in every product twice as a result. And it's changed a good amount in the 3 years since it first launched. The reason we're looking at this one is because we've actually seen these getting made in the factory. So that's a pretty cool different angle that we can provide. Before that, this video is brought to you by ASUS and the ROG Crosshair 8 series of X570 motherboards for AMD. ASUS has both the Crosshair 8 Hero Dark and the Crosshair 8 Extreme available, offering high-end motherboards for high core count AMD systems. We've used the Crosshair series for years for everything from basic overclocking up to liquid nitrogen overclocking, and we found them easy to work with, particularly for their extremely well-organized BIOS menus. Learn more at the link in the description below. All right, so this power supply, as stated, when we did our Cooler Master power supply factory tour, they use a contract manufacturer for it, like most companies. So Cooler Master doesn't own or run the company that actually makes the bulk of the product. However, it provides the spec. It works with that company on design and engineering. I guess at this point, we'll just go ahead and say it's HEC that was doing it when we did that factory tour. They didn't want us to say who it was when we did the tour, but it's been long enough. Everyone's figured it out by now by looking at the products that they were making, so it doesn't matter. So it was HEC, which is in the southern part of Taiwan. And they were making these types of power supplies when we were there. HEC has many other clients that would include EVGA to some extent. And the way that power supply manufacturing works in general is like most of the more complex products like video cards, where the companies that brand it, that design it, that do the cooler design, the spec, go through a lot of the engineering, they then seek out a contract manufacturer who puts it all together and helps manage the technical side of it or the engineering side of it if there's something like PCB or board design involved anywhere in the process, if the company making the request is incapable of maybe doing the full design on its own. So this comes from that factory that we toured, and we'll put some of that footage on the screen if you want to see it, or you can check the description below for our factory tour video and our R&D lab tour video. The main changes in the 3 years or 4 years since this came out would mostly be in the caps. Originally when it launched, a lot of the complaints from people were about capacitors that just weren't rated that high. The fact that they were 85 degrees Celsius caps instead of 105 was one of the main negative points people had. In our unit here, however, all of the caps thus far have been 105 degrees Celsius ratings, except for the most important one, which is the bulk cap. That one is still an 85C component. And some of the suppliers have changed as well, like for example, going to LTEC from TPO previously for some of the components. Now, general specs, consumers get a very cost-effective targeted offering here at, again, 55 bucks. It has a 5-year warranty. Its claim is 80 plus bronze efficiency. We have a whole piece on 80 plus certifications now. If you're curious what it really means, a lot of people think it means more than it does. And 650 watt rated continuous output power. You can do all of that on 12 volts if you wanted to, or you could split it as is more perhaps realistic. So that's enough of the primer on the power supply. We're going to transition over to Patrick Stone, who's going to look at the internals and talk about the quality of components as we then ramp into the benchmarks. And as a reminder, our benchmarking process for this, we are still defining. We've added some more stuff to it, and we're building on our power supply testing as we go. So our goal is to start testing enough of these that we can provide not only the singular data for a product and if it's good, but the comparative data, so that over time you'll know, okay, maybe this one's good, but is something else that's maybe the same price or cheaper better. That's what we're working towards. We'll get there. And as always, if you want to support our efforts as we add new types of testing, like component testing for power supplies and soon fans, you can go to patreon.com/gamersnexus to support us and get behind the scenes videos. We've just published 2 with the 2 Patricks, and I've got a behind the scenes video going up over there soon as well if you want to see some of that. Or you can always go to store.gamersnexus.net if you'd like to get something high quality in return for your support, like one of our mod mats, which we've just restocked. They are in stock and shipping right now. People have been back ordering them for months and months. They're finally all going out, and if you want one, you should grab one quickly because we sell through them fast. All right, let's go over to Patrick Stone for a look at the interior of the power supply.
All right, so let's get right to it. My favorite part of any hardware review is, well, the hardware. So let's look at the components. All right, so we'll start with the AC plug and the power switch. There's a little bitty PCB that's connected to those, and that joins the main PCB through these wires here. We'll talk about that in a second. But on this little PCB, you can't really see much other than this one choke right here, this common mode choke. But there are also two Y caps right here spanning this little area, and then there's an X cap that spans both pieces. I guess you could probably see that guy. It's the little gray piece in there. So on this little mini PCB, we have the two Y caps, the two X caps, a little microcontroller, and then that common mode choke. Then that feeds out to these two little spade connectors. And this is a nice thing because the spade connectors allowed us to disconnect this piece of the power supply from the main PCB. So it connects over to these spade connectors, which is a plus for serviceability. But we want to remind everyone again that if you're not professionally trained and working with power supplies, you probably shouldn't be opening up and servicing your power supplies. Once we do get on to the main PCB, the first thing I want to point out here is this little fuse. We got this fuse for safety. It's a 12 amp, 250 volt fuse. And that then leads to this next piece, which is a little MOV, which gives us some surge protection. Then we have another common mode choke, another X cap, two more Y caps. And then if we swing around to the backside over here, there is also a third Y cap that's on the main PCB. So that gives us all of our EMI transient filtering slash protection. And then we are led into the APFC and boost. All right, so to make this stuff happen, we've got two GBU 1006 bridge rectifiers. These guys are both 10 amps and 600 volts. You can tell that from the name, the 1006. And if you're ever trying to figure out what the specs are on a bridge rectifier, you can look at the name and get a rough estimate of what it's going to be capable of. From there, we've got our usual inductor and capacitor. In this case, the capacitor, this bolt cap is an LTEC bolt cap, which is a 470 microfarad bolt cap that can do 400 volts. Unfortunately, it's 85C instead of 105C. We'd love to see 105C. That generally indicates a higher quality part and will make the bolt cap last longer. From there, we're going to come to the back side, this top piece right here. We got this controller. This is what controls both the APFC switching and the main switching. It's a Champion CM 6800 XT. For the APFC side, you can see the components right here. It's this guy, and this guy. Two MOSFETs and a diode. The MOSFETs are both great power GPT 18N50Ds, and the diode that's working with those is a Hestia H3S065A004. If we keep going down this heatsink, you'll see another MOSFET, and then there's actually another one on this side next to the transformer as well, but it's a little bit tougher to get a camera angle on. Those are the main switching to get the power up to a high frequency for this transformer. And then the transformer feeds the primary side to the secondary side and steps down the voltage for us. So on the secondary side, we'll start by looking at what happens with the 12 volt signal. The 12 volt signal appears to be rectified from the transformer using a set of 4 diodes. The diodes are over here, 2 on this side of this heatsink and then 2 on this side of the heatsink. We might even be able to see one of them right about here. The diodes are from a company named PY. The model number is PSM40U60. And the 12 volt signal is then filtered by going through this inductor, and we got some electrolytic aluminum caps. And from there, the 12 volt signal also goes out to the modular PCB, and there's some more filtering caps over there. We'll talk more about that in just a second. Let's move on to the 3.3 and 5 volt. Both of these guys are done on vertical PCBs, and both of them are done using synchronous DC to DC rectification, which means we've got a DC signal coming in, and then it outputs a lower level DC. So in this case, like a 12 volt coming in, and then moving out at 5 volt and 3.3 volt. The PCB layout's pretty similar. What we have is a set of 4 MOSFETs and a single controller. The controller is this little guy right here, and you can see it on this board, and then you can see it again on this board. It's an ANPEC APW7164. and it's controlling these four MOSFETs. We might be able to get an image or a shot of one of those guys right there. There's actually, like I said, 4 of them, 1, 2, 3, 4. And those MOSFETs are POTENS, P-O-T-E-N-S, DD3906s. So the 5 volt and 3.3 volt are filtered using their own independent little inductors or chokes, and then that is sent to capacitors for further filtering. And then just like I mentioned on the 12 volt, we have additional capacitors over here on the modular connectivity area. The capacitors, if you want a brief breakdown of them, we have 8 from Eltec, and 8 more of them are from Chensun and their Elite series. And then to wrap things up, we'll spin it back around one more time. You can probably see this fan connector right here. So the fan connector is on another vertical PCB, and it's actually controlled by a little fan controller. It's an APW9010. And then on the other side of this PCB, we see one more IC, this guy right here. That's a well-trend, a WT7527V, and that is a protections IC. So that takes us through pretty much all of the components. And every time we open a power supply, we're learning something new, getting better at the topologies, learning more about how power is moved up in voltage and down in voltage, how the current is handled, what kind of safety mechanisms are built into this thing. Speaking of which, one of the safety mechanisms I did forget to mention was this one does in fact have an NTC thermistor right here, this little green one, and that's one more safety mechanism. In this case, that's specifically to handle inrush current to prevent the rest of the power supply from being beaten up. All right, so that does it here, and we'll send it back to Steve.
We'll next look at the product marketing and the target audience for the Cooler Master power supply. This will include the claims that we're validating against and things like the packaging and the assembly quality. The packaging is fine. It's strong enough to keep the device safe. It's nothing special, and it doesn't excessively waste things like plastic. The only plastic was the bubble wrap for the power supply body and a small bag for the power supply screws. Outside of that, the cardboard and the manuals are recyclable, the twist ties are reusable, and so things are overall about as cut down as they can be for Cooler Master. And that's a good thing, even if it's for cost savings. The provided manual is sparse, but it's adequate for a power supply anyway, and there's more online if you need it. The case is a standard stamped steel case. It's used in most power supplies. There's a hexagonal mesh for intake and exhaust, and all of this can be made mostly with bending machines in a factory, making assembly easy since the bulk of the housing is a single sheet of steel that's been bent a few times by a large press machine. We've seen a lot of these in the past. We've got some good footage of it from factory tours if you'd like to see more, and it's all the same tooling or machines that are used in a case factory. So most of the time, the power supply chassis comes out of, say, a Lian Li factory or maybe a factory in Guangzhou or somewhere like that, where Cooler Master makes its cases as well. In this instance, of course, Cooler Master would be using its own suppliers. The power supply is semi-modular, so the ATX 24-pin and 4+4-pin CPU cables are permanently connected to the PCB. Both of the permanent cables are sleeved, while all of the modular cables are unsleeved and molded together. The 5 modular outputs provide connectivity to 3 drive cables and 2 PCI Express cables. 2 of the drive cables have 4 SATA connectors, and the third one has a connector combination of 1 SATA, 3 4-pin Molex, and 1 floppy drive, just in case you want to go back to that. The 2 PCIe cables each have 2 6+2-pin connectors. As always, we recommend using only 1 cable, so that'd be a 6+2 rather than daisy chaining it for a high-end video card. Cable lengths are acceptable, although we do prefer more length on the CPU cable for ease of cable routing to the EPS 12-volt connector. The packaging and online information both tout 16-gauge PCIe cables for decreased resistance to GPUs, although how much this matters on a $55 power supply is questionable, seeing as other elements of design will potentially be a limiter anyway. And 16-gauge isn't that abnormal. Time to get into some of the test data. The MasterWatt 650 Bronze has an official 80+ report that verifies that it was, in fact, lab tested, and that the sample met or exceeded 80+ bronze rating at least at one point. And if you're curious why we're saying that, we'd recommend watching our How 80+ Works video, where we explain the rating system and the fact that power supply makers only need to really send 1 unit in so they can send a golden unit and then change things later. This simple bar chart will start us off. The GN lab result showed we were within error of the 80+ report for the power supply, so that's good. That means hopefully there's no skullduggery going on like with the AGS 850. The 80+ gold result gives you an idea of the gap between the load level efficiency at the different levels. Cooler Master passes the 80+ bronze spec in our testing at every level, although at 100% load we're within error. Considering we test with different equipment, the 0.5% point gap here is reasonable, and we agree with the bronze rating. This is a more standard efficiency chart, so some of the data is the same, but the comparisons are a little more standard for an efficiency curve. The GN lab result has us at just 59% efficiency when under the newer 2% load for the Cooler Master power supply, and then it's 80% efficiency for 10% load. These two results are most likely to be encountered when in various sleep, hybrid shutdown, hibernate, or idle states, or low power states in general. So these are numbers that'll matter when you're not using the computer, but it's still sitting there on. Peak efficiency hits around 40 to 50% in our testing. The claimed results are close by, but a bit higher on average. And the bronze and the gold marker lines help show the floor and the ceiling for this testing. For the bronze rating, the power supply must have a power factor of 0.9 or better at 50% load. The Cooler Master sample tested at 0.99 in its 80+ report, and our testing produced the same result at 0.988. Even at 2% load, the unit has 0.896 power factor, so the APFC implementation is good here. The MasterWatt 650 showed relatively strong 12-volt regulation across all of our tested loads. It only varied 0.3% as shown here. We see that it started off at 12.1 volts for our 2% load test. It hit 12.09 for 10% and 20% loads, and then it stayed at 12.07 volts from the 30% load up to the 70% load. It stopped at 12.05 volts for the 100% load, resulting in a total voltage drop of 0.05 across our entire sequence. The Cooler Master power supply didn't fare quite as well on lower voltage rails. At 5 volts, the voltage started 3.9% higher at 2% than it ended at full load, with an average range of 3.6%. After the initial 2% load, there was a steady decline of 0.02 volts for each of the remaining loads, and this created an almost linear downward graph. This result doesn't meet our preferred target of less than or equal to 2% variation. So far, for some of these, Cooler Master is falling short, and for the others, it's just okay. The 3.3 volt rail got close to the outer limits of what's acceptable, starting out at 3.38 volts and ending up at 3.18. For reference, the ATX voltage regulation spec limits are 3.47 and 3.14 volts for that range. Much like the 5 volt output, the 3.3 volt rail had a steady downward trend as the load on the power supply increased, and the resulting regulation across loads was 5.8%, which is good enough for the Intel ATX spec, but then again, Skylake was good enough for Intel to stop trying for a decade, so we have higher standards. We'd like to see this number below 2%. But technically it's fine and it's within the spec. 5 volt standby performed well with a variation of only 2.2% across all loads. It started and finished fine between 5.25 and 4.75 volts. The total drop was just over 1/10 of a volt at 0.12, which is acceptable. And it started at 5.06 at 2% load and finished at 4.94 volts at 100% load. This chart looks at voltage ripple, including not only the ripple that remains from AC to DC conversion, but also the noise surrounding the ripple. As we stated in our last look at power supplies, almost any unit is going to meet the Intel power supply specifications that ask for a maximum and obscenely bad 120 millivolts peak to peak on 12 volts and 50 millivolts peak to peak on 5 VSB, and 3.3 volts. Because we, however, like things that aren't garbage, we set the standards considerably higher, with 30 millivolt peak to peak and 25 millivolt peak to peak being our respective goals. For viewers considering a power supply for overclocking, we show an 80 millivolt cutoff line for the 12 volt rail, and that's what we would consider the break point for too much ripple for a good overclock. On each of the tested rails, voltage ripple got worse as we increased the load. At 100% load, the 12 volt rail performed respectably at 51 millivolts, but it still exceeded the desired 30. It is, however, a $55 power supply, so maybe that's expected here, and it's still not bad. All three of the other rails at 5 volts, 3.3, and 5 VSB were within the Intel standard mark, registering 34, 39, and 34 millivolts, respectively. These numbers aren't bad, but they are all outside of our desired measurements. We aren't yet running thermal tests for power supply reviews, but we'll add that as we go. We've added a few tests for this round already coming up. Cooler Master is using a 120mm Silencio FP with a maximum RPM of 2500 and rated for 0.16 amps at these standard 12 volts. The bearing is what Cooler Master calls a, quote, loop dynamic bearing, which appears to be its creative way of describing a rifle or maybe an FDB, designed to pump the lubricant during operation. When we attempted to open it up from the backside to investigate the claims, we found that it was sealed by molded plastic. For this one, rather than destroy the fan and continue taking it apart, we decided to let it live. However, we are planning to add more fan testing in the future, including some destructive fan teardowns. That'll all be coming soon. It'll be coming when we get to our new facility and start working with our fan testing machine that we just purchased and is on the way. And that expensive purchase is supported by our viewers on patreon.com/gamersnexus, who've been getting behind the scenes videos. Thank you to all of you who've helped us fund this machine equipment purchasing. And also it's been supported by store.gamersnexus.net buyers, because the mod mats are back in stock and shipping now. If you've wanted to grab a PC building work service, it helps us buy high-end equipment like the fan tester. Our function testing is last here. For short circuit protection, we verified that the MasterWatt 650 bronze shut down correctly when shorted on each of its different power connectors and voltage rails. In testing OCP, we saw trip points that ranged from 114% on the 3.3 volt rail to 150% on the 5 VSB rail. The 12 volt rail tripped around 140%, but we typically see the trip point closer to 130% OCP for component safety and longevity if it meets our preferred result. The 5 volt rail also had a high trip point at about 130%. For overpower protection finally here, our unit tripped OPP without exploding at about 918 watts, or around 140%. That's another high OPP value that could be reduced, maybe to 130% if there were ever another revision of the unit, but it worked and didn't explode. Overall then, the voltage regulation and ripple are pretty good for a $50 power supply. You get some okay features. They're mostly standard things, but at this price class, it's doing pretty well for what it is. We bought this retail. It was the same price we've been saying this whole time. It's got two sleeved cables for the ATX 24 pin and the 4+4 EPS 12 volt cable. So it's not bad. It's not fancy, but you get partial modularity and some sleeving. The efficiency did end up lining up with 80 plus bronze. So there's no funny business going on here like with the Aries Game power supply. And ultimately we would be comfortable recommending this from what we've seen so far, at least on this unit, for a mid-tier gaming PC, something where you're not going to be overclocking too much, not just because of capacity, but more because of the performance overall, but it'll do completely fine for something like, say, 5600X, 5800X, 5900X, anything like that, 10700K. If you start getting into serious overclocking, you should probably buy a better power supply for it. It'll make your life easier. Ripple and regulation will be on the better side if you spend more money on something that's good. But again, if you're building sort of a budget tier system where you're not going to be doing a whole lot of playing around in BIOS or with crazy overclocks or anything, this is fine. And we just need at this point to look at other power supplies at the same price, because as stated, you all are used to, if you see our reviews, us having a chart with dozens of things on it where we can say, not only is this fine, but it's better than the other things on the chart, or this is okay, but it's below average. We're not there yet with power supplies. We're working towards it. You'll have to give us time. Each one that we review, we get to add to a future chart to do that comparison. Standalone, however, strictly looking at this in a vacuum, we don't have any major issues with it. And at $55, the It's Fine badge does seem to fit. And then as we review more, we'll be able to adjust that badge to see if it deserves something better or something worse, depending on its competition, which is how we always look at things. But we'll get there. So no explosions. The value seems good for what it is. And regulation and ripple are in okay territory for the pricing. That's it for this one. Thanks for watching. As always, you can go to store.gamersnexus.net if you'd like to grab one of our mod mats, which are again in stock and shipping now, including the Volt design that's been wildly popular. Or you can go to patreon.com/gamersnexus for some behind the scenes videos with Patrick Stone if you like his presentation. Thanks for watching. We'll see you all next time.